All right, sample problem 3-3. A chemist produced 11.9 grams of aluminum, which is represented as Al. How many moles of aluminum were produced? And you can see that this is the exact opposite direction of sample problem 3-2. In sample problem 3-2, we were given an amount in moles and asked to calculate the number of grams that were contained there. Here, we're given the number of grams and we're being asked to figure out how many moles that represents. Okay, so it's the same type of conversion. We're still going to use molar mass, but it's just going the opposite direction. And I'll try to point out how the opposite direction changes the conversion factor. Again, we've been given an amount in grams. We're being asked to calculate an amount in moles. Okay, again, conceptually, this is what we're doing here. Mass of aluminum in grams convert to amount of aluminum in moles. Again, for those of you who are visual thinkers, go look at figure 3-11. It's in your book. You just got to scroll back a little bit. But it's a visual cue to help you conceptualize what you're trying to do here. Go down a little bit. Okay. So what we're going to be doing, and try to notice the pattern here. You'll see that the units are kind of flipped, but the idea remains the same. I take whatever unit the question has given me to start with. In this case now, it's grams. And I'm going to have to convert grams into moles. Okay, so I'm definitely going to use a conversion factor. Absolutely true. But I still have to cancel out of this unit. So the only way I can do that is to have that same unit on the denominator of the conversion factor. And you can see that the unit that I'm trying to convert into is on the numerator of that conversion factor, leaving just the unit that I want. Again, I'm going to use the periodic table to look up the molar mass of aluminum. Happens to be 26.98 grams per mole. And because I know where to put my units, where the units are lets me know where to put the actual numbers. Then I can trust my setup. I know what to multiply. I know what to divide. I end up multiplying, in this example, 11.9 by 1, and then dividing by 26.98. At this point, students really start to think, well, how do I know if the 1 goes on the top or the bottom? I say, what's your statement of equality? What's your statement of equality? In this example, from the periodic table, we see that 1 mole of aluminum is equal to 26.98 grams of aluminum. So, well, what number do I put in front of grams? Whatever number is in front of grams in your statement of equality. What number do I put in front of moles? Whatever number is in front of moles in your statement of equality. Okay? It just so happens that in this setup, we flip the conversion factor because we're, again, going kind of the other direction. And then we'll check out the evaluation. The answer is correct given 3 significant figures. Right? Because the question gave us that 11.9, and that's 3 significant figures. So my answer needs to be reported to 3 significant figures, even if the calculator tells you more than 3 significant figures. The answer is reasonable because, well, 11.9 grams is somewhat less than half of 26.98 grams. Just giving you a ballpark there. Ballpark. Again, that's sample problem 3-3.